Today we are going to talk about the area of triangles, much like squares and rectangles that we did last week. This should be probably a review for many people, but even if it's not a review for you particularly, it should not be challenging. For our warm-ups, we are going to find the area of these polygon shapes. What is the first shape? How would we classify it? It's a quadrilateral, but more specifically it is a square. They marked all the sides the same. They marked all the angles with 90 degrees. So how do we find the area of a square? Keon. Okay, so we take the side length times itself. We square it. Our area is a side length squared. So as Keon said, that means we're going to take 15 and multiply it by itself or square it, and we would get 225. What would our units be? Centimeters squared. Area has units that are squared. Number 2, what kind of shape do we have?
Rectangle.
A rectangle. What's our formula for area? We can call it length times width, or we can call it base times height. What's our base?
12.
What's our height?
16.
We take 12 times 16. What are our units? Meters squared. How are we going to handle number 3? Split it up. They already split it into shapes for us, which is nice. Once we find the area of all 3 of those, what would we do with them? Add them together. Okay, Keon, let's fill in the sides.
The left side to the long rectangle.
Over here?
6.
Okay, I would agree. 6 feet.
The left side to the square is 4.
Okay.
And the top of the bottom triangle, is that another 4?
Yes.
I mean,
This rectangle down here, that is also 4 feet at the top of that little rectangle. I think that's all that we really need.
What about that side, the whole side?
We don't need this whole side because none of the shapes use that whole side all at one time. We could find it, but we don't need it. So on this first rectangle here, we've got 6 feet by 2 feet. What would our area be? 12 feet squared. I'm just going to put a 12 for right now, and I'll write it up here. Okay, my next one looks like the square here off on the side. So it would have 16 feet squared. And at the bottom, what are my dimensions? 4 and 2, so it would be 8 feet squared. 36 feet squared altogether. Our last one, number 4. A rectangular mural has an area of 504 square feet and is 12 feet high. What is the length of the base of the mural? So in order to do that, I'm going to make some space above it and take away number 1. If we're dealing with a rectangle, what's my formula for area? Base times height. Let's fill in what we know. Do we know the area on number 4? What is it? Do we know the base?
12. That's the height. Right?
That's the height, so we don't really know the base. We'll leave it as a B. What is the height?
12.
12. How are we going to get b by itself? Divide both sides by 12. What do we get for our base? We're on number 4. Do we agree with 42?
Yeah. It's 42.
It's 42.
What would our units be?
42.
Would they be squared? No, only area has square units. All right, today we are talking about area of a triangle. The formula is area equals 1/2 times base times height. So it is very similar to finding the area of a rectangle, except we are multiplying it by a 1/2 also. You should see a space on your notes where it says note. Right? You see that under where the picture goes? So it is important to note that the height has to be perpendicular to the base. So H is perpendicular to B, is the short way of writing it. Perpendicular means that it has to form what kind of angle? A right angle. So notice that in the picture it does that. The height and the base form a right angle with each other. If it does not form a right angle, then that's not the height. It's just a side of the triangle. See how their height comes down through the middle? It's not actually part of one of the sides of the triangle. Sometimes if you have a right triangle, it will be one of the sides. But we do not always have right triangles. On number 1, they have a right triangle there. You should be copying that down. Fill in your notes. Also the one on number 2. On number 2, if it's hard to see it, on the inside here where we have the height, it is labeled as being 4 centimeters. 4 centimeters for the height. On number 1, in case you can't see it, they did mark a right angle on the inside of that triangle. So number 1 is a right triangle, which means that the height is the side of the triangle itself. All right, at the top, I like to write my area formula just so that I remember it. Sometimes, including on the activity we might see tomorrow, we might see a little triangle as a subscript next to the capital A. So this means area of a triangle. So our area formula is, Martez, do you want to tell it to us?
Wait, what's it like?
What's our area formula for a triangle in general? You should have just written it down.
1/2. 1/2.
Good. 1/2 base times height. So what Julian just asked was, don't you just multiply it together and cut it in half? And that is true. Multiplying by 1/2 is the same as dividing by 2. So on example 1, when we plug all this in, we have 1/2 times, what's my base? 12 times, what's my height? 5. So either you can go in order and just do this from left to right, multiplying them all together, or you can multiply your base and height together and then cut it in half. Either way, you should end up with the same thing. What is half of 12? 6. 6 times 5 is 30, we should have units, inches squared. Even though we're not dealing with squares and rectangles, we're still dealing with area, and our units on area are always squared units. Questions about example 1? Mariah is correct, but we're going to go ahead and show our work. We're going to take 1/2 times, what's my base? 8 times, what's my height? Okay, now the other way of doing this is to just go ahead and multiply 8 times 4. What do we get? 32, and then cut it in half. That's where we get the 16. So either way you want to think about it is fine with me. What are my units? Centimeters squared. I'm not familiar. All right, on example 3, I've got my formula back up at the top in case I need to use it. So we'll plug everything in. Area equals 1/2 times, what is my base on number 3? 14. What is my height? 5. Notice that the height goes perpendicular to the base. If it's not perpendicular, it doesn't work. All right, half of 14 would be 7. 7 times 5 is 35. My units? Feet squared. All right, on number 4, same process. 1/2 times, what's my base? 9 times, what's my height? 6. Now, this might be one where you want to multiply the 9 and 6 together first, because taking half of 9 gives us a decimal. It's not very fun. So what is 9 times 6? 54. That we can cut in half. It would be 27 inches squared. Good. Now, it is possible that you could get a decimal as an answer on these. Not all area is perfectly a whole number. Okay, it is possible to get decimals as your answer. Just, it didn't happen on these ones. All right, now we are trying to find the missing measure. So our area formula for a triangle is still the same. The area of a triangle is found by taking 1/2 times base times height. This time we're just going to plug in what we know as we go through it. Do we know the area of the triangle?
No.
Yes, they gave us capital A. A is 15. It's not 15 squared. The inches are squared, but we don't need to actually square 15. Equals 1/2. The 1/2 stays where it started. What's my base? 10. And my height is what I was looking for. So probably easier to see on your paper than the screen. The H is just going to stay in H. That's what I'm trying to find. Couple ways you can do this. One way would be to just take half of 10 right away. What's half of 10? 5. So 15 equals 5 times H. To get H alone, we would have to divide by 5. H equals 3. What are my units? Inches. Should they be squared? No, we were not finding area, so we should not square those inches. All right, same process on example 6. Do I know my A? What is it? 126 equals 1/2 times. Do I know my base? No, so I'll just leave it as a B. What about my height? 12. Now, even though the 1/2 and the 12 are not right next to each other, multiplication is commutative. So if you liked how we did this first one, you can still take half of 12, which would give you 6. So you can still rewrite this as 126 equals 6b. So we divide both sides by 6. B equals 21. My units? Centimeters. We have to talk about areas of similar polygons. So what's in the box up here is what goes in, or sorry, I'll put it in a box. What's in this box that I'm creating goes in your box on your paper. If two polygons are similar with a scale factor of A to B, then the ratio of their areas is A squared to B squared. So we can find the ratio of the side lengths, and we can also find the ratio of their areas. We get that copy down? Let's talk about our last example. So we are told that the triangles are similar. Remember, that's what the little squiggly, the little tilde in the middle means. Those triangles are similar to each other, which means that all the angles should be congruent and all the sides should be proportional. That's something we covered a couple chapters ago. So we are trying to find the scale factor, or the ratio of the side lengths, of triangle DEF to triangle ABC. So when they give it to us in that order, that's the order we have to go in. So give me a side length from DEF. Nobody can find me a side length from triangle DEF. 6 is a good option, the bottom side there. And we have to compare that in a ratio, or you can write it as a fraction, to the corresponding side from triangle ABC, which would be 10, and that would reduce to be what? 3/5. So that is my scale factor of the sides.
3F.
Scale factor, SF, scale factor.
You put 3 over.
Ooh, because I was thinking about writing scale factor already. 3/5. Then that theorem that we just wrote in the box above says that to find the area of the ratios, what am I going to do to my scale factor numbers? Square them. So my area ratio is 3 squared over 5 squared. 3 squared being, and 5 squared being 25.
Oh, you said 5 square. Sorry.
So those would be what goes on your blanks.